Thank you so much. I'm so pleased to be here, and it's really an honor and a pleasure, and I would first like to start by thanking Jocelyn and Sternen and the scientific committee and the organizers. It's really an honor to be presenting on such an amazing venue, you know, with the landscape. We're here to talk in these days about heritage of the Arab world, but of course, this really gives you a deep sense of the importance of French heritage, you know, and it's an inspiring place to present. So if you think 9 a.m. is early to get up, this is one of the only ties I own, and I had to get up really early to remember how to tie this thing, but it's a reflection, I think, of how grateful I am to the opportunity to be here and to speak with you today about these important topics. And also I've been looking at the windows here of the Institut du Monde Arabe. It's such an inspiring place, sort of reflecting the history of art in the Arab world and also the technological aspect of this piece of artwork. I haven't yet find someone to ask about how this came to be in this room, but it's really inspiring. So I think recently I've become, as I get older, thinking about not only the artifacts that we find and how they're important to understanding the past, but also to the role that archaeology plays in heritage diplomacy. And in such a tumultuous world, we sort of look around ourselves and think about the places that we work and care so deeply about, and see so much turmoil and so much violence and so much to be concerned about. And this makes it really quite difficult. And especially coming from the United States, we hear all the time these messages about engineering, science, and technology, that this is what we should be studying, this is what we should be devoting ourselves to. And that's obviously deeply important. But what I want to really communicate to you all and to people online and in the audience is just the deep importance of what we do in studying history, culture, archaeology. You know, it's such an inspiration to see the tremendous work of French work in Saudi Arabia, for example, Jerome Romer and Leila Naime, who we'll hear from later today. My colleagues at Itinéraires and the amazing scholarship that they're doing, and how this is really, I think, in 100 years, when archaeologists and students studying the archaeological past are looking back, they're going to remember how significant this is for partnerships between Saudi Arabia and France and these kinds of heritage diplomacy and the knowledge that's built and the partnerships and the alliances and the friendships that are a consequence of this important work. So really, I just want to start by highlighting how important that is. So let me go on to focus in on the archaeology before I get too far into these modern issues. So I'm going to talk today about copper and softstone in Southeast Arabia, specifically in the Sultanate of Oman, and really focus in on my team's work, and a lot of credit goes to my co-authors, which I'll mention a lot. But I'm going to focus in on the Iron Age and chlorite trade and copper trade. So some of the sites we've been working at, in 2015, in partnership with the Ministry of Heritage and Tourism, we discovered the site of Kir al-Shamus. This is the first site known with large-scale manufacture of chlorite softstone vessels, and I'll show you some pictures of this. And since then, we've been working to find the quarries, the sources of chlorite, in conjunction with my PhD student, John Shannon, and Hélène David. And we found 3 quarries. These are shown up here, Wabi el-Zaidi, Shwagi, and one near the village of Hayakur. And so a lot of our work has gone into trying to understand where are the raw materials coming from to produce these chlorite vessels, where are these vessels being traded to, and what does this tell us about the social network, the economic and political network that produced this material and traded it widely throughout the Gulf. We've also been working deeply on copper, and this is really spearheaded by my colleague Joseph Lehner at the University of Sydney. And he's just tremendously knowledgeable through his PhD work in Turkey about ancient metallurgy, including in copper, about this type of work. And he's devoted these skills, including lead isotope analysis and analysis of copper, to sites in Oman. So this is some of his work looking at the sources of copper throughout Arabia, and then also the slag deposits. So there's some important Bronze Age, Iron Age, and Islamic sites in Oman with large deposits of slag, up to tens of thousands of tons of slag. And it's tremendous when you think of the time, the energy, the work, and even the sort of fuel, the wood fuel that went into producing this kind of slag. So one of the sites we've been focusing on is called Raki. It's north of Yankel, close to some of the softstone sites we've been working on. And there was some really important German work done here in the 1990s. There's huge deposits of slag. So this is Joseph Lehner's, skipping ahead. This is Joseph Lehner's team's excavation of these slag deposits. So literally, unlike excavating a settlement or a tomb, this is digging through slag. You know, it's really heavy. It's really a laborious task. But even some of the buildings at Raki are made themselves out of slag. So they're using this slag debris, so much of it mounded up meters high, tens of thousands of tons of this, to produce architecture in which they're inhabiting and smelting this. So some of their work has been generating radiocarbon dates from the deposits at Raki. So there's a number of different sites in Wadi Raki, Raki 1, Raki 2, and Tawi Raki. This shows you some of these radiocarbon dates. And one of the things they taught me is to get reliable radiocarbon dates from this slag. What you can do is start to break open pieces of slag. And if you break open enough of this slag, sooner or later you find a piece of charcoal inside, which can be radiocarbon dated, which the species of wood can be identified. And this is a definitive piece of evidence for the age that this slag is produced. So there's lots of recycling and reuse of slag, especially in the Islamic period. Interestingly, there's almost no Bronze Age artifacts from Iraqi. These sites are almost entirely Iron Age and Islamic. But one of the radiocarbon dates come back as a very early 3rd millennium date for a piece of slag. So there was some bronze, copper smelting activity there in the Bronze Age, but most of it is Iron Age. Now, one of the other things we've been working on is using different satellite imagery technology. So this is some of my expertise in computer mapping and satellite imagery work. One of my students, Alex Sivitskis, he was a very energetic undergraduate student who took a real great interest in this. This is him with a field spectroradiometer. This is an instrument that takes a reading like a satellite takes from space. But to calibrate and to ground truth our detection of things on the ground, this is one of the tools we've been using. So you adjust this thing with this white board that adjusts the illumination. And then we've been using this with multispectral and hyperspectral satellite imagery. So if you're not familiar with this, a normal color photograph is in 3 bands RGB. Multispectral satellites like Landsat that have been around since the 1970s break that down into other bands or wavelengths of infrared light. And then hyperspectral imagery, unlike Landsat that has 8 layers or 8 images, hyperspectral imagery has upwards of 240 layers. So you can distinguish a lot of different things on the ground. And one of the things we've been using this for is to detect and map slag deposits. We can walk around these with GPS and we can map out the extent and try to estimate the volume of slag produced, and then use dating to estimate how much slag was produced at what periods of time. But what we've also been doing is comparing those on-the-ground results with satellite imagery detection of those slag, and we've been able to map it with upwards of 90% accuracy using multispectral and hyperspectral imagery. Another really important collaborator in this work is an Iranian-Australian student, now Dr. Amir Zaribaf, who really did a tremendous recent PhD work on estimating the the biomass, the fuel used to create these tremendous deposits of slag. So they did a above-ground biomass survey, basically surveying the trees and estimating biomass from trees. Because all this slag, we're talking millions of trees that need to be used to create the charcoal to smelt this copper, right? And this is his map of estimating in hours how far you'd have to walk from Raki to get a certain amount of biomass in wood to create the slag. And then on the left, the map of the Iron Age impact zone and the Islamic impact zone. So by the Islamic times, the quantities of copper being produced are absolutely massive. They're recycling the Iron Age slag, so they're using, instead of mining new ore, they go back to the slag that the Iron Age people are producing. They're re-smelting that with better technology in which they can extract more copper from it. But they're also using a tremendous amount of wood, and estimating this is quite important. Another really important piece of their work has been looking at the periodicity of copper production throughout Arabia. This is yet to be published, and I really am putting up again Amir and Joseph's picture here because this is really the brainchild of their work at the University of Sydney. But if you look here at Timna, Wadi Faynan, and Oman, what's really quite important, this is from published radiocarbon dates in the literature, is that I don't know if the shading can quite appear there, but what this is showing you is that in the 5th millennium, 4th millennium, and especially here, let me see if I can use the pointer. Is one of these the pointer? Especially here, you see in this 1000 BC Iron Age period, the really big peak in copper production is something that's not specific to one area, that has in common with the southern Levant and Southeast Arabia. And even some of the other peaks here in production, we like to think today about the global economy and the GDP dropping by a certain percentage point and what drives these boom and bust cycles in global trade and economics. We can look back even in the deep ancient past and find evidence that these wide-scale cycles of economic activity reflected in copper production are happening on a synchronous or somewhat synchronous basis throughout the Arabian Peninsula, so that there's a common economic link between these areas that we see also in traded artifacts, but also in the magnitude of copper production. So I'm really excited to see them develop this in publication, because I think this is something really important. And of course, the tremendous work going on in Saudi Arabia in areas where there's major copper sources and major copper production. Some of the analysis of that and integration of that with data from other areas is really critically important. So where is all this copper going that's being produced? I think one of the places is a couple of really tremendous and fascinating sites, one in Oman called Safa or Uqtat al-Baqarah. It goes by both of these names, and the other where John just came from, team excavating Saruq al-Hadid in the Emirate of Dubai. Both of these sites, like Safa, are really remote, out in the desert sand dunes, when seemingly, why there's over 600 bronze artifacts being discovered out in these sand dunes has been really quite mysterious. And so a lot of really tremendous German and Italian work focused in on the recovery of these artifacts and conservation of these artifacts. So lots of bronze, and I'll show you more of pictures. And also these little pits, or sometimes they're called furnaces. Some of our research is focusing on what exactly these are used for. Are they used, there's no slag at this site. All the slag's at Raki. There's almost none at Safa. But there's these thousands of these little pits or furnaces used for either producing charcoal for fuel, or maybe for recycling or secondary metal production, or perhaps even for food. So amongst the many artifacts found, these are examples from the courtesy of the tremendous work led by the Oman Ministry of Heritage and Tourism. Daggers, axes, bowls. A lot of these are in the Oman National Museum and other museums in Oman, just tremendous, fascinating materials, and there's been some incredible work doing the drawings and the photography and the conservation of this that my team is not involved in, I should importantly note. But our work is focused on the remote sensing at Safa and the understanding of the environment of the site. So why is the site out in the desert sand dunes? Well, I know I'm in a room of people who enjoy walking back and forth in the heat of the sun in the desert. But even you may get tired on the hot days. And so we initially did some ground penetrating radar work, as shown here, which is really time consuming. This site is over 25 hectares, and it takes a long time to drag a GPR around this radar system in the desert. We've also been using satellite radar here, so this is optical imagery and satellite radar, and the tremendous thing about satellite radar is it's penetrating the ground surface up to a couple of meters deep. So you can see things buried underneath the surface of the ground from satellites, which has tremendous potential if you think of throughout the Middle East, Egypt, the Arabian Peninsula, elsewhere, how much archaeology is buried in sand. Loose, dry sand is the ideal matrix for penetration of radar waves into the ground and radar imaging. But of course, this can be very tiring and time-consuming. So one of the things we really have been working on, given Americans' kind of obsession with cars, and these days with autonomous vehicles, we have our own autonomous vehicle that we've been working very hard to try to make this work. Drive in a grid pattern. This one only goes like 5 kilometers an hour. So, okay, it's not fast. And the reliability is somewhat problematic thus far. But we are working very hard to make this little vehicle drive in a grid pattern and autonomously in the desert and collect ground-penetrating radar data that will give us more insights about what's buried underneath the surface of the ground at this site of Safa. Other notes about the possibilities of lead isotope analysis of copper. These images are from Western Oman in Dhofar, and this is the work of Joy McCorston, my mentor, and her team. We excavated a tomb, a unique type of tomb called a Haluf tomb, just named after the wadi that was found, Wadi Haluf. But interestingly, this tomb yielded an important dagger of the early 3rd millennium, and Joseph Lehner's team did lead isotope analysis on this dagger. And because the copper from this dagger could have come from Yemen, could have come conceivably from Saudi Arabia, could have come from Oman, this lead isotope analysis is a way of establishing the age of the ore source for the copper, and shows that indeed it really appears that this dagger, DA 22914, more likely comes from northern Omani copper sources in the Al-Hajar Mountains, and less likely comes from Arabian Shield sources that are found in Saudi Arabia and other parts of the Arabian Peninsula. So a lot of data they've been producing is still underway, under analysis. This is one of Joseph Lehner's undergraduate students did this analysis of this one dagger for her undergraduate honors thesis. So on to softstone chlorite vessels. Of course, many of you are familiar with the tremendous softstone vessel trade of softstone that was produced in Iran and traded throughout the Gulf into Mesopotamia. There's some just absolutely stunning examples of iconography of imagery on this type of material, but also softstone vessels and chlorite vessels being produced in Southeast Arabia and in Oman. Some of these we know wind up in Mesopotamia, like these 2 examples here found at Ur, and these are based on their form, style, and the material very likely originated in Southeast Arabia and Oman. And Hélène David is really one of the most knowledgeable and important members of our team. It works in close collaboration with John Shannon, my PhD student. Other examples here of chlorite from Oman finding its way into Mesopotamia. This is one of the most striking examples. These are images from the Penn Museum in Philadelphia, And if you were questioning whether this came from Magan, it also has some cuneiform on it that also reiterates this Magani or Omani origin of this material. So these pictures don't do full justice to the cuneiform here, but this is an important piece of evidence. And there's dozens of examples of softstone with cuneiform on them. This is just one of those types of materials. So our work really got focused in on chlorite after discovering this site of Akir al-Shamus. This is a small village in the mountains where we've documented over a metric ton, I think a ton and a half of chlorite. Very few decorated or finished pieces. This is all raw pieces being shaped into vessels, broken things that are discarded, all pieces underway in the throes of production even before they're been moved. So one of the initial questions at this site was, where is the chlorite coming from? Because there's no chlorite quarry right near the site. So we started to use satellite imagery. We detected a chlorite source called Wadi al-Zaidi that's about 1.4 kilometers away, up in the mountains here, very rugged mountains. So finding our way up here, we found this chlorite source. There's a handful of artifacts around this chlorite source. We thought, oh wow, this has to be the source for the chlorite. Then we did some materials analysis, and this is what John is going to talk about here in a moment. We started out with neutron activation analysis at Murr in Missouri, and one of the little bit confusing results was that Wadi al-Zaidi, the source, doesn't match the chlorite from the site. So then we started to think, well, are we missing? Is there some other quarry? We started looking further, trying to find other materials, and John is going to discuss his PhD dissertation work here on this topic really briefly.
Yeah, thank you, Mike. So I have been working in the laboratories in Baltimore at both Towson University and Johns Hopkins University doing geochemical analysis of chlorite, both artifacts and raw materials from the Oman Peninsula, sort of to try to better understand where exactly the raw material for vessel production may have been coming from. And to that end, I have implemented this sort of multi-pronged analysis in which I'm combining bulk geochemistry with spatially resolved microanalysis. And so for bulk geochemistry, I'm using wavelength dispersive X-ray fluorescence and LAICPMS of fused disks. The complicated thing about chlorite, about softstone, generally is that it is a heterogeneous material. Unlike something like obsidian, which is relatively homogeneous, you can just throw it in the XRF and be good to go. You need to powderize it first and flux it with lithium borate in order to get a homogeneous sample for a bulk geochemical analysis. These images down here on the bottom, I know they're kind of dreadfully boring. They kind of look like printers, but I promise they can do really interesting things. So on the bottom left here is our Teledac C-Tine laser and the LAICPMS next to it that it's hooked up to. And for spatially resolved microanalysis, I'm using optical petrography to analyze the sort of characteristic mineral heterogeneity of samples, and then using scanning electron microscopy with EDS to compositionally map them, and then from there targeting specific phases within the mineralogical ground mass with LAICPMS to get a down to parts per billion resolution of the mineralogy. And here are some very early results of the XRF that I've been doing at Towson University. Again, this kind of reiterates what we've seen with neutron activation analysis, that Wadi al-Zaidi and Akir al-Shamus do seem to be relatively distinct. Now, we do have a ton and a half of chlorite refuse littering the surface of Akir al-Shamus, so it's totally possible that there were multiple sources involved. Multiple quarries that were, the stones were brought to this site for production. Definitely, I'm looking forward to getting more of these samples analyzed. We have over 300 in the lab at Johns Hopkins, and I've only done about 40, so there's still a lot of work to do. And then the Shwagi quarry down here, sort of in between. This is just looking at relative chromium and zirconium values. And up there on the The top is the autofluxer that I use to create my little lithium borate disks and the wavelength dispersive XRF at Towson University. So that's sort of what I'm doing for my dissertation. There's still a lot of work to be done, but I'm hoping that it yields some interesting results and we can finally figure out where the stone for these things may have been coming from. So I'll pass it back to Mike.
Thanks. So importantly, these three sites that a lot of our material comes from, as well as other samples, and so we're looking always for other teams that are able to share material that we can analyze and try to determine the sources. So we have quite a few samples from different parts of Southeast Arabia and other places, but importantly, this site of Chouagui was found by Hélène David in the 1980s in conjunction with French geologists. So the French team was doing geological mapping of Oman, and they found her and said, hey, we know you're an archaeologist. We found this place where these artifacts or stone artifacts looked like they're being quarried, and they took her here. But at Chouagui, there's no site, there's no pottery, there's no date. It's just a quarry, and it's not a modern quarry because the modern people aren't quarrying it. But this analysis holds the promise to be able to distinguish locally between some of these three different quarries that we know about, and also the material being produced in Iran. Also, my student Paige Paulsen, just to finish off here, has been working very diligently on the Iron Age settlement pattern and Iron Age distribution and mobility patterns throughout Southeast Arabia. And so she's been mapping some of these sites like Akir al-Shamus. One of the questions surrounds, this is a really small village for producing over a ton of chlorite. What is the social structure, the political structure of production here? What's the level of inequality? Is there some kind of leadership? One of the things that's so remarkable about Magan, about Southeast Arabia, is unlike Egypt, Mesopotamia, even the ancient Aztec or Maya, we don't have evidence of striking inequality. We have quite remarkably no royal tombs or palaces or temples that are these grand edifices to individual leaders. Like in other parts of Arabia, we have a lot of tombs in which everyone, men, women, young, old, immigrants, even people with disabilities, are interred in the same type of tomb, which is so remarkable. And this is one of the big questions we've been looking at. What is the political structure? What is the social structure of these sites in the Iron Age, including Akir al-Shamus and a larger town near the site of Raqi called El Akar? One of the buildings here may very well be a public building, and so most of the buildings are small and don't portray any dramatic inequality. And Paige has also been working here quite diligently, doing something called from everywhere to everywhere modeling. So another high-tech sort of jargon term. But the inspiration for this comes from Devin White and Crabtree. This is a recent publication where they did this paper on superhighways throughout Australia. And what they did is use topographic models. And so you basically string a series of points across, in this case, the continent of Australia, and model the most efficient route from point A to point B of all these different points, right? And then look at what are the most efficient paths to get across this continent. And this, of course, takes incredible computing power. It's not something you're able to run on your laptop. But Devin White is really a wizard at this kind of work and works for a national laboratory in the United States. And then they've started to plot the early archaeological sites in Australia along these pathways and realized that these do bear some correlations to the type of routes of movement used by ancient people. So Paige has been doing this for Southeast Arabia on supercomputers at Johns Hopkins, and really started out doing this on quite sophisticated computers in my lab until she realized that even for the area shown here, you require tremendous computing power. But this shows you the sort of paths, or it's sort of a type of least cost path modeling that a lot of people do in GIS, but it's modeling the routes from everywhere to everywhere, essentially. And this is the Iron Age sites that we know from the tremendous work by Jeremy Chitiket in producing databases of sites in Arabia plotted out here. We haven't done sort of statistical analysis, but when you start to plot out the sites on the routes, you start to realize that a lot of these sites, like Saru Khalidid here, are seemingly out in the middle of nowhere in the desert sand dunes, but they're also on a pathway, on a route that is explainable in a certain sense by the availability of water and of a travel corridor that leads you into the Gulf. So we'll just conclude here with some acknowledgments, of course, to the people of Oman and the Omani Ministry of Heritage and Tourism. It's been an incredible pleasure and an honor to be able to work in Oman. We've had some tremendous help and support by local Omani people, including local families who have pointed us to some of these sites and have encouraged us to explore areas in their backyard that they know are places with some tremendous archaeological remains. And also a lot of my collaborators from the University of Sydney, the Australian Research Council, National Science Foundation, NASA, and others. So thank you very much for your time and the opportunity to present, and I look forward to hearing from so many of the interesting papers to come.